Hello and welcome to a new episode on Hyperbolic Orbits Podcast. When we think of the space sector, there are three major industry pillars that we think of. First is the space agencies, the national space agencies. Then there are aerospace primes, the companies that have been serving the space sector for many, many years. And then there are the startups. Today, our guest has officially covered it all. We have with us GK Rama Murali, who is currently the head of AIV at Space Inventor, leading all assembly, integration, verification, qualification, and industrialization activities for satellite production. He is a seasoned space systems leader with over 16 years of hands-on experience at premier global organizations, including Airbus Defence and Space in the UK and the Indian Space Research Organization, ISRO. Prior to his current role, he served as a systems AIV manager and test preparation manager at Airbus, defining and managing integration and test activities for advanced microwave instruments and telecom payloads. During his extensive tenure at ISRO, he held multiple key positions, including program manager for space applications for strategic customers, project manager and systems engineer for several of India's most prestigious deep space and remote sensing missions, like the Mars Orbiter mission and the NISAR. Rama Murali's expertise spans the project lifecycle from mission formation and satellite systems design to AIV and applications development, of course, implementation as well as operations. He has significant experience managing diverse global teams and collaborating with multiple international space agencies. Applying his technical background to industry strategy, he is also pursuing a doctorate in business administration focused on the emerging commercial space ecosystem. He's a dedicated STEM ambassador and mentor, actively supporting the next generation of space professionals. Murali, thanks a lot for joining us today.
Thank you. Thank you. That's very nice of you. Thank you.
Glad to have you, and I'm most interested in understanding how did you arrive at such an interesting career path?
As always, for every one of us, mostly who are from village background in India with studying in our own mother tongue or first languages, and then moving to a city for higher education. And that's the same story goes to me as well. And then again, because of our backgrounds, normally we wouldn't know where do we want to go, or because of the struggles of when we do the education or engineering. Normally we wouldn't think much, okay, we just need to complete the engineering, get a job. And that was mine as well. So, but what happened is eventually when I was just completing my graduation at Bangalore University, so I had a couple of offers from multiple, like 3-4 offers from the industries, because I was doing, the only thing what I was doing is I was doing well what I was doing. That's the only thing I would say, which made me go through all these experiences. It was a very interesting story, how I ended up in ISRO. So basically I had 3 exams planned for that day. And I had to pick one because all were on the same day. That day morning I got up, I was just casually talking to my friend and I said, okay, let me go to this because it's very close by, the center is close by. And that's how I ended up writing ICRB, and that is how I ended up joining ISRO. So that's what made me to get into the space industry. Then once I cleared the ISRO offer, then I started thinking, okay, what do I need to do? I have 3-4 options in front of me. I consulted some of my professors and family members. Just this is something I do all the time throughout. Even this is what I do even till today. Is whenever I get into a crossroads or an options, like I have multiple options and I need to choose one. Normally I go to expert opinions or those who have gone through similar things, and I just ask what would they do if they are in the same path. Then most of them suggested, okay, this is a very good offer for you. That's how I ended up in ISRO. But maybe to my luck, I ended up as a space systems engineer for Chandrayaan-2 mission. And that happened by luck. And again, another luck I would put it is I had throughout my career, whether it is in ISRO or outside, I had some amazing managers or mentors. And I think that basically made me what I am today. If I'm good at something today, I should thank them, because that's where I think they played a very significant role in my career progress, of course. What happened is we were working on Chandrayaan 2 mission, and there were some reconfigurations and some change of plans. It was around 2009-10. So, and sometime during 2000, end of 2010, beginning of 2011, there was a requirement. Along with Chandrayaan 2, I was also supporting other missions in terms of while doing the testing and for the test support and all the systems activities, basically interface definitions and requirements definitions and all. That's how I started learning what is systems engineer. And sometime during end of 2010-11, there was a need to form, basically, there was some study report being formed for Mars orbiter mission, and they were looking for people. And I don't know, again, thanks to the mentors, they just chose me. And that's when I think I had a very great learning experience. That is the first project where I worked from identifying the requirements all the way to the launch and almost operations, reaching the Mars orbit. So that's where I learned the entire project life cycle. And it's not that I was only supporting that. I was also working on other missions, as in different phases of the mission. But this is one mission, I would say, where I learned a lot, because it was first time. There was a lot of schedule requirements, because with the capacity we had at that time, we could only do that launch at that time. And if we had missed, it would have missed by 5 years. So it was just a do or die kind of situation. So we had to step up and we had to do things right. And at that point of time, there was even a national committee formed to study, are we doing it right? So it means what we had to do was we had to study all the Mars missions across the globe, why they failed, what made them fail, and why it won't happen in our mission. That was the first task given to me to study, not just me, as a team. So yeah, that gave us a lot, at least to me, a lot of inputs into, okay, this is what normally happens, this is what happens, this is how the requirement should be, and should not be, and this is where we may go wrong. We always learn from failures. And it's important for us to know, it need not be our own failure. We can even learn from others' failures. So it's important for us that we study what has gone wrong and implement it in our system. We take care of in our system such that we don't do the same mistake. So that was a very good experience. And then again, all the system engineering activities, and even the good thing about my role that time was basically it was not just a systems engineering, the standard definition of system engineering role. In that role, I had to even take care of the schedule and the coordinations and all those activities as well, like some project management tasks as well. And the role was more like a project manager for the non-AOCS systems, basically the RF, the baseband data handling, and all those systems. Like that was my role. TMTC, all those systems were my role. So it was very interesting, because identifying those critical requirements and ensuring that those critical requirements are met, and while developing the system, because in ISRO normally there are no outside suppliers. Everything it's a fully vertically integrated system. So all the subsystems are developed in-house. So the good thing about that is I can actually sit with the designer and understand how he designs a system and how he tests a system. And when they do this design and testing, you will actually know, okay, what to look for and what not to look for when you're designing. And I think at some point of time, that is very important. And if you know that key, like when you design a spacecraft, okay, these are the key things you need to look for when you are picking a system. It need not be just the spec. It's some specific activities, practical aspects around each system. And that's where I think I had a very good learning sitting with those designers, what to know what they are doing and sit. And the best thing about ISRO, even now, is the review system. And that review system is like something, it teaches everyone in the system. Like everyone can be part of that review and everyone can ask questions. And it is very hard to implement in very big organizations because if there is one satellite mission going, there are multiple satellite missions going on parallelly. So it is very hard for everyone to participate in every project. But I don't know, that is actually, we should be thankful to the organization of ISRO, how it has been formed, because everyone can participate in every project's reviews. It need not be every review, but at least milestone reviews. And for example, the pre-shipment review at ISRO, how it used to happen is before shipping the satellite from satellite center to the launch, it's a very big review and it happens in an auditorium and everyone participates and anybody can ask question. It's just an open review. There is no need for reads in advance or anything. It's just you come to the auditorium and ask. And if that question is not answered, the satellite is not shipping. And that was that is something amazing. And those kind of reviews actually it's not just about reviewing the system as such, whether you did it rightly or you built it, tested it rightly. It's also for learning for everyone in the team and the organization. Okay, this mission has these criticalities. Okay, this is how it works. And I think most of the organizations, this challenge is the communication. And I think this review system actually clears a lot of things in that communication. So yeah, those reviews and the system actually built me what I am today. And subsequently, in later part of my life, when I started working in Airbus or even in my current role, those lessons or those learnings, what I learned from them is very helpful. So that's how the career path is. So
all of that hard work paid off when we saw the Mars orbiter mission reach. I mean,
yeah,
the orbit capture, that insertion part was so thrilling, and it went like first time. It was a huge success, and that was remarkable. I can assure you, we were all clapping for you.
it feels very old because it happened in 2013, almost 15, like I think almost 13 years old now. But the thing is, I still remember what I remember those days is those challenges we faced, not the easy parts. We had to, like, I still remember calling somebody from the team in the middle of the night to get us some components. The person he was sleeping in his midnight, like 12:30, but we had to do that, otherwise we are sleeping. The schedule was we were working the schedule like 30 minutes, and we had two plans. If this plan doesn't go, we have alternate. If this doesn't go, so it was just every 30, and I have never seen any project working like 30-minute schedules. It feels crazy, but we could make it happen. The best thing is, even now when I meet anybody from that team, everyone remembers and appreciates the efforts we did that. And that's what like keeps us going. So
I think it's not even just passion, it's a lot of dedication and discipline that you
yes
showed.
Something I think I should say that it starts from home, and it starts from a very young age, how we see things and how we take our day-to-day activities. If I have learned one thing so far in my career is, whatever is the task, whether it is just cleaning something or taking some printouts or stapling those, everything is important. You should do it so perfectly, like do it as if it's the only work. It may look very silly, but it's very important, because when you build a space system, there is no room for errors. You can't correct it. And whether it is like, for example, there are many missions failed off because of just a bug in the software. There are many missions failed because of 1 mm, 2 mm gaps. So everything is important and everything should be perfect.
I see a lot of self-help personality development coaches say this: how you do one thing is how you do everything. And I
Yes.
think it somehow seeps into your everyday life too. You bring that dedication and discipline to everything.
I think sometimes it is the perseverance as well. Like you may feel like, okay, I cannot finish it. Okay, let's leave it and move to the next one. But it is the last leg always gives you the success or failure. That last delta, the about to reach, and then you don't complete it, then it's gone. So yeah.
Now, we hear about space organizations collaborating globally. That happens. But as an individual, how has it been for you crossing continents? And then it's also a multicultural environment that you've worked in. So, how has it been the growth journey for you?
Yes, actually, again, when I was in ISRO, I had opportunity to work with JPL teams or European Space Agency teams or other teams, and even Indian industries. So it was not just an inside organization role. So I was moving the roles. So that was maybe again, I was lucky enough that I could work in different streams of the satellite phases, like whether be it in the planning phase or implementation phase or even application development phase or implementation phase. So this way, I think that gave me a kind of global perspective, and it changed the way I look at things. So that helped me a lot. And to add to that, for example, the working in the NASA ISRO synthetic aperture radar, in the initial days when the project started, we were only 2 or 3 of us working on the mission. It was just an kind of regular interaction happening with the JPLT. But the thing was the system engineer, because when you start a mission, normally the documents as a system engineer, you are responsible for system engineering management plan document or the procedure. So this is where I start, because when you work with the outside organization or agency, you need to align your practices and processes to the other system agencies' practices and processes. And there is a lot of interaction happening there at the systems level. So I think these kind of things gave me, and further when I was working with the customers at later point at ISRO, I think that gave me what actually customers are looking for and how we define the spacecraft missions accordingly. These kind of interface, I think the interactions and coordinations, this helped me further in my career when I moved to Airbus, because again, it's a process. There is ECSS or any other processes. So it's whether you do it that way or this way, it's just the minor differences. But at the end of the day, we develop this satellite for space, for specific mission. So I think these kind of basically different type of experiences and interaction with the multiple agencies helped me to take up these roles. And further, even when I was working in Airbus, I was lucky that I could work with multiple customers, including ESA and the commercial customers. And their requirements are totally different. What commercial customer looks and what ESA demands, they're totally different. But still, I was lucky enough that I could work on both the streams and I could learn, okay, what is needed, what is not needed. And all those experiences, I think today in my current role, I'm able to take decisions and implement new processes and productionalize, industrialize the AIV because of all those experiences I gathered. So yeah.
That's wonderful to know. Now, what you're doing right now in AIV is an important part for everyone, for every space mission. But especially, since this is not something that is usually taught in universities, it's also very difficult. How do you put an AIV curriculum in a practical curriculum in a university? Yes. So if I ask you, how would you define and explain it to someone who is maybe going to do it tomorrow, let's say in a company?
Okay. So this is something I was talking in a conference, and this is something while preparing notes for that, I was just going through. And one interesting thing I found out is, like, now we talk about a lot of commercialization of space. And the profit or loss of a mission is decided by AIV, because that's where actually the satellite is made and tested. And a 1 day saving there or 1 hour saving there is direct profit for the project. And if we get into non-conformances during that phase and we are not able to resolve that, it's a loss for the projects. And the majority chunk of the money is spent at AIV, assembly, integration, and verification. Now, what is it? So I think the one equivalence or a similar example, if I can give, is the Legos. So we built Legos. Legos is some very famous, popular toy every kid is aware of. So we build Legos. What we do, we look at an instruction manual, we keep all the pieces around us, what is needed for building that, and we build as instructed in the assembly manual. That's the thing we do. Let's say we built a car. Then what we do is we check whether it works. We just move around. Once we built it, we just take it and slide it around and see it works as it should work. And that's exactly the same thing we do with the satellites. Slightly differently, because you cannot really have a space. It should work in space, but we are working in a clean room or on Earth. So we need to simulate those conditions and do that. That's the only thing we do. Now, and if you look at a satellite's journey, the satellite, basically the components and the modules and the subsystems units are built in some different labs, and it all comes together in one single place in the clean room, and they all get assembled together and integrated together. They all should speak to each other, and then it goes to the rocket. It sits in the rocket as a satellite, and it gets launched. During the launch, it experiences a lot of turbulences, be it the noise, be it the vibrations, or everything. It goes through a rough phase of the travel, and then it gets ejected into the space. And space, as we know, it's a microgravity environment, and it is extreme temperatures. For example, when it looks at the sun, it gets a different temperature. When it is not looking at the sun, it goes to a different temperature, and it needs power. So when there is a power, the condition is when there is sun, its conditions are different. When there is not, its conditions are different. So it has to work in all those conditions. So we need to build the satellite and test it, verify it that the satellite can work in all those conditions. And that's the only thing we do at AIV. So we collect different subsystems or parts from different suppliers. They all come and meet in the clean room, and we take individual part by part. We see that those parts are delivered as specified, and there are no non-conformances. So what is non-conformance is basically, so when you build, for example, in a spacecraft mission scenario, you build spacecraft mission for specific requirements. Let's say one spacecraft should work for taking a picture of Earth at this rate. Like every day it should look at this place or these areas. Every day it should look. That is the objective. Or there is a higher level objective, why it should look and that's a different story. Now, everything is broken down further. So to look at that area, what do I need? I need an image, that's a camera. So what type of camera? I need a spec for that. Now, just camera is not enough, because it has to be in a specific position and orientation in specific orbit, because it has to do the repeated observations or the specific observations for what it is designed. Now, to meet that, there are specific systems needed on the satellite. The camera should be held this way, and that should orient this way. And during that phase, it should be able to image for 4 minutes, 5 minutes throughout the orbit. So these are all different requirements are there, and they're all defined in the beginning of the missions as a systems engineering, what normally system engineering role does. So all these requirements are further broken down even to the component level. For example, okay, this is the imager I need. To image this is the camera I need. The camera is broken. What is camera? It needs all these XYZ elements, and for that, these are the requirements. So when we receive these items to the clean room, we just need to ensure that what delivered to the clean room meets all those requirements for which it is designed. And that's the first step of verification. Normally, verification, we see it in 4 phases. It could be by inspection, it could be by analysis, it could be by review, or it could be by test. So we identify the beginning of, okay, these are all the requirements, and this is how we verify these requirements. It could be by inspection, analysis, review, or test. So we collect all those requirements which should be verifiable by test, and we test it in the clean room to meet those requirements. That's what we do in the testing. And so the AIV part covers this aspect. So that is where we build the system and we ensure that all those systems are built and it is verified. The requirements are verified. Once we collect the units, we assemble them together and we integrate. So integrating is like you have multiple subsystems. We put them together in there is a mechanical housing or the structures. So we assemble them and then integrate, connect all the harnesses, the connections, be it RF cables or the power or the signal. And then we ensure that those systems can talk to each other. And then once they talk to each other, then you know that, okay, once the assembly and integration is complete, then comes the testing. And then we start the testing. And testing could be done in different environmental conditions because, as I said, it experiences different environments. So we test for vibration, shock, radiation conditions, and thermal conditions, vacuum conditions, everything. And we see, and we even, another thing is maybe satellite is designed with some specific thermal, there is thermal design for the satellite, and that thermal design also needs to be verified whether we are doing it, whether it can work as we designed. So we do all those testing and then we take it to the launcher, integrate and launch. So that's what happens in an AIV.
This is something that we can only learn from someone who works in the profession. This is what you just described is impossible to get even an overview of if you had not really worked on it for so long. And this is connected to my next question, which is the most interesting, most frequently asked system engineering based question is we do not get this kind of curriculum in our bachelor's. For example, in BTech, there are some universities abroad where they teach systems engineering as part of aerospace, but naturally, this is a practical field.
Yes.
So what do you suggest to someone who is maybe even studying postgrad right now and to bridge that gap between theory and practical knowledge?
I would say it's not like we think we don't have it in our curriculum, but it's not really true because we do it in day to day. Like, for example, we build things, we check things, but we don't name them or we don't define what we are doing mostly. We do it regularly. Like when you get a toy or something or a chair or something needs to be assembled, we do that. We do even check whether it works, but we just don't name them. That's it. Even when we cook things, we take all the ingredients in the right places, we put them together, and we even test it before eating, whether it's right. So there is AIV in everything, but just that we don't name them as AIV, that's it. So, and for those who wants to start, I would say there are a lot of opportunities today, as I see it in India, at least from Indian perspective, is all schools have labs and all schools have some clubs, like whether it's go-karting club or car making club or drones, UAVs, robotics, AIML. You have a lot of opportunities. But what we are not doing is, we are not, let's say we have a robotics club. When we build a robot there, or when we need to build a robot, we don't follow the process. We just do it our way, which is okay. But maybe we need to improvise there a bit by maybe putting everything on paper and planning it before we do it, and then we do it. We do some. I have seen some people doing that even. And the first thing for any students or who wants to get into this kind of or get a first-hand experience would be to join those clubs. That's the easiest way. Or if you don't have access to the clubs, go to the labs in the colleges or schools. They will get something. There will be something kept, some very old equipment, instrument, anything. Just start from there. Just have that curiosity to see how it is working, what is working, and what happens if I do this. What happens? I think that part I see that it's a missing in the today's education, as everyone says, and I do agree with that. That we do not really think creatively. We lose the creativity part of it. So we don't really think why it is. It needs to be done. We do it. Or if let's start from there. If I need to study engineering, why? Why I should start engineering? It's if it is not something I like, why? I think it has some links to even culturally as well, because we were never told to ask questions. We were always told to follow things. This is how it is. You just follow. Don't ask it back. So maybe it starts from there as I see it. But I think it's slightly changing as I see in today's new education system. There are improvements coming in, but maybe it has not reached where it has to reach. But there are improvements happening.
I do see a lot of options in schools, colleges, everywhere. Even when I studied versus now, there are so many options. But I think that lacking part is that curiosity of asking why.
And another thing what I found out is we normally go with what is the narrative happening outside. Today, AI is the big thing. Everyone starts looking into AI side. Okay, now AI is the trend, so we get job only in AI. It's not so. I think somewhere we are lacking, because some years back it was computer science. If you study computer science, that's it. You don't need to worry. You didn't need to do it. You just get a job. I understand from where it is coming, because everyone have their struggles and making ends meet is the requirement. So that's where it starts. But somewhere, I think so society-wise, we have moved that phase. It's no more to make life, to live is not a question now anymore. It's not a survival requirement anymore. Everyone can actually afford to think a little bit further. And I think that thinking should start now. And that's where we can make the difference, I feel.
I want to ask you one thing, that at what point, because the age is also a factor when we are at university and starting even in the beginning years of our career. How do you balance that? One is that expectation to earn a living when you start a career. And that should be, nobody should work full time for free. But the other part is that somewhere that's where the curiosity is getting lost. And I do see that in a lot of space startups as well. They're doing it because it pays now. So where do you think you can draw the line or make a balance?
But if you see anywhere across the globe, there is no free lunch. There is money everywhere in whatever we do. And I think it is good, but we should start adding that to everything. We shouldn't even for example, when you start, okay, you completed engineering and then you're moving to and get a job. You should never do it freely, because you have studied 4 years of engineering and for that you are getting a job. It's not a free thing you should be doing. And I think there's some regulations and some that part also should play some role there in terms of minimum wage or the salary for the right skills. And again, it has multiple dimensions, because when you say you passed engineering, you completed engineering, that doesn't mean that you are still actually an engineer in today's world. So there is some effort needed to make them a proper engineer when they complete the 4 years. And then they get the right job and right salary. then I don't think anybody will feel any other way. And again, it has another dimension to it, because we are driven by society in most of our decisions. For example, what I need to do after my 10th standard, or uh, for the graduation, it's decided by my family or the society. And that should never be the case. Everyone should start from there, actually, what they want to do. And they should do that. And I don't see, if everyone start doing that, there will be definitely enough employment, and there'll be enough skilled people for those jobs. The only difference where it comes is everyone becomes engineer, because there is a craze for computer science. So you will see millions becoming computer engineers. Then you don't have that kind of many options for the jobs. Definitely not. And next thing comes, nowadays, everyone is getting into AI. So they go to the college and study AI ML. Now you should imagine, like, how much there is limited space in every domain. But when everyone moves to, there is no balance now in the ecosystem. There should be balance. And that balance only can happen if everyone starts pursuing their passions. If somebody is liking music or art, they should pursue it as the profession rather than considering it as a hobby. And if they are confident, and it's something to do, so if they constantly develop the skills, they can become a good professionals today. There are plenty of options today, but I think somewhere the society is driving everyone's future. So that's where the problem comes.
It's very well said. It's a very good advice. I think this trend hopping, that's where the saturation comes.
Yes.
And that's where a lot of disappointment also struggles. Okay, I don't have any more.
Normally, we used to make fun with my friends. So everyone will first become engineers and then they think what to do. It's the truth, actually. It should not be. And and again, it comes from, because most of them may not have that kind of exposure, what to do. So they look for mentors, and the only mentor they get is the people around them, and they suggest something and they end up there. So I think there is a bit effort needed from those who are in the system to go back and create this kind of awareness among the younger crowd, where what could be the options. And that should come from every domain, not just technology or space or the STEM. It should come from every domain, like an artist or a player, sports person, or let's say literature researcher. These all should go to the different, like they should go back and say that what is good in there.
I remember this, my college counseling incident. I went to study engineering only because I wanted to study aerospace. And very well-meaning mentor of mine told me, why don't you choose at the time of counseling, I was just registering, and he said, why don't you choose this other field? It is very popular. This is what the college is known for. Aerospace has 2 core companies. You will never get a job. It was a difficult thing because my parents are sitting, and luckily they said, no, it's fine. It doesn't mean aerospace is not going to grow. Yeah. But I can understand that parents may also feel a bit scared if suddenly 4 years later they have nothing to do.
You know, I when you said this, I remember something. Like, I normally go back to my college from where I am from, and I interact with the students, and normally we do some mock interviews and whatnot. So when normally I see the trend today, so the students are like, okay, even if I study electronics, even if I study mechanical, even if I study civil, I should learn a Java, Python, the software program, then only I will get a job. That's what is the normal trend today is. And that's where the problem comes, because if being a civil engineer or mechanical engineer, if I don't focus on my field and try to do better there, how that division or that vertical grows. As a civil engineer, I should think from that perspective and how I can develop that domain. It starts from us, actually, like every one of us who study engineering. If we don't do our jobs, when we are told to study, or we chose something to study, And when we don't study that well and we just look elsewhere, what's happening across, and we just go behind the flow, that's where we don't do any innovation we don't do any justice to our course. And then how do we expect everyone to become a good engineer when they complete the studies? Because we all end up studying that last 1 week for the exam. And you know that out of 5 questions, 3 questions need to be answered. So I know these 3 questions, okay, out of this 10 last 5-year question papers, if I mug up all those correctly, I can at least pass some 60-70%, and that's it, done. I'm done with the engineering. And that's where the problem is. I think that should slightly shift. And it was, even when I studied, it was the same. Like when I was like, we were in electronics, a few of us were really into electronics. So we just wanted to focus on electronics and do something. But the most of the flow was like, okay, we don't get jobs in core electronic industry. There's less. So let's study some C++, Java, something, and try to get a job. I understand that urge to get a job and efforts, but if that efforts are focused in the right areas, they can actually do much better job in their area. So that's something, my observation maybe, yeah.
That's an excellent observation and advice too. And now that people have, not just students, even professionals have a lot of options, but especially in space, I would say everywhere, in every country, there are emerging economies too.
Yes.
So what would you recommend to anyone who is just starting off from a different field with a good amount of expertise, and they have to decide, okay, either I join a big corporation, an agency, or a new company? So since you have tread all the paths, what would you recommend?
Maybe this is something space industry or it has taught me, is like everything is connected. So you, at the end of the day, you work for, like, for example, you become a mechanical engineer, civil engineer, or an electrician, or a technician, or a software engineer. There is room for everyone. Even if they want to become, like, you know very well that if somebody wants to get into the space industry, they need not be just an aerospace engineer. Even as an artist, today people are getting into space industry and they are well established there. So everyone has room in every industry. And space industry is just that you build systems for space, whereas automotive is just you build systems on Earth for transportation. That's the only difference. And how we do things changes based on where we operate and how we operate. So so that's something, like anyone who is pursuing different areas of the career, what they should focus is doing their job. Like as we were discussing in the beginning, whatever they are doing, even if they're writing an essay or writing an exam, they should focus on that and do it to their 100%. And they should do it perfectly, and that will take them to the next level for sure. And if they don't focus there and do that, it's good to have future visions and everything, but the future visions should be supported by the current efforts as well.
Thank you, Murali. This has been such an episode full of pearls of wisdom, if I may say, learning from
philosophy.
No, it's such practical advice, because it's very rare. A lot of times I see, especially students who are just finishing off post-grad, MTech especially, they get the most amount of advice, but also the most amount of confusing advice.
Yeah.
And because they have to choose between going into academia and then going into industry. So what you said is a very clear, crystal clear picture. Okay, this is how it is. Now, this is what you need to do. So Thanks a lot for sharing this. It's been educational. This has been inspiring, and learning from someone who has sent spacecrafts to, I think, hopefully in the coming years, we will also send spacecrafts to the far edges of the solar system.
Hopefully.
So this has been a true honor to have you. Thank you for taking the time out and joining us from such a northern latitude during winter months. That's a special thanks that goes to you. And to everyone watching, I would say, please keep following this podcast, subscribe to this channel. This year, I think I did a little bit better with more episodes. And next year, I promise that I'm going to bring more guests who can tell us about what space industry is and demystify it.
I should thank you and what the efforts you are putting in, like consolidating these expertise and bringing it to those who are needing this. It's very, very remarkable, and keep doing it, and best wishes.
Thank you. This is much needed. Thanks a lot.